Lewis structures are representations of molecules in terms of types and numbers of bonds and lone pairs. So here's this first step. If you're given a formula, so in this case you have carbonate. Well, the first step you need to do is you have to find your inventory. You have to calculate or add up the number of valence electrons from all atoms. So let's begin. Number one, you have one carbon atom and you have 3 oxygen atoms. I like to list them like that so that you can see them. Obviously, you can say 3 times oxygen, so that works too. In addition, you need to pay attention to what the rule says here. So I should say add an electron to instead of from. Okay. So number one, you have to add up the valence electrons. So go to your periodic table and find the number of valence electrons. We should be good with this. So we have carbon right here. How many valence does carbon have? Well, it's in group 14. We look at the 4. Remember, this is 1, so I'm going to label them once again so you can see it. So this is 1 valence. This is 2, 3, 4, 5, 6, 7. Helium is still 2. And again, the noble gases, all of these are going to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Just look at Roman numeral and you'll be fine. That's 1, that's 2, 3, 4, 5, 6, 7, 8. Okay, so carbon has 4 and oxygen has 6. Carbon has 4, or this, and oxygen has 6. So let's go and write that down. 4 valence. Oxygen is 6. Since we have 3 of them, so that means 6 each. Okay. Find the valence. Then you have to pay attention to this. It says for every negative charge, add an electron to the total number of valence electrons. For every positive charge, subtract an electron from the total. So you know this already, that negative means it's gained an electron and positive means it's lost. So correspondingly, you have to add for every negative charge you have, add an electron for every negative. So what's the charge here? That's a -2. That means you have to add 2 more electrons. Okay, 4, 6, 6, and 6, and 2. If you add up these, you get 24 valence electrons. This is your inventory. And you have to remember one thing is you must use all, no more, no less. If you use more, you're violating the law of conservation of mass. Same thing if you use less. So if you use more, well, where did you get the extra from? Out of nowhere? Can't be. So once again, please, okay, pay attention to that. So let's keep going. I'm going to move quickly now. More. So my inventory is 24. So now the next thing is connect central atom to outer atoms via single bonds. Least electronegative atom is usually the central atom. And in this case, if we compare which one would be the least electronegative atom, and the reason why is because it's better at sharing. You want something to be in the middle, sharing electrons, than something that doesn't want to share. How is that going to work? So in this case, it would be carbon. Why? Well, I look at the electronegativity table, and I see that carbon right here is 2.5, oxygen is 3.5, as we discussed before. So therefore, carbon is less electronegative, and it's going to be the valence. It's going to be the central atom. Just remember one thing: most of the time, but not always, but most of the time, the central atom is written first. So I'm going to write here central atom is written first. So in this case, C is written first. And then I need to add also one more is H, hydrogen, is never a central atom because it only has one valence. How is it going to form more than one bond? One valence electron. So it's never a central atom. Okay. Since we have CO3, 2 minus, means C is in the middle. And the oxygens are on the outside. And I connect them via single bonds right here. Okay. Let me make this a little bit. Now, 3 single bonds. This one is still not as good as I want it to be. It's just the pen here is not working. Okay, better. So this is what you have so far. Now, what you need to be aware of is before you move on, you need to remember how many electrons you use so far and how many does each have in this structure so far. Okay, well, we know, and I'm going to use it only for this one, we know we have 2 electrons in a single bond. Okay, so in this case, this oxygen has 2. Here they are. This oxygen has 2, and that oxygen has 2. Because remember, double counts. That's what sharing is. Remember the children analogy. And this carbon now has 6. 2, 4, 6. Okay. Let's move on to the next one. So it says complete the octets of outer atoms first, and then place any leftover electrons on central atom. So let's copy this down so you can see the progression here. So again, so far we have, I'm only using these dots only this time. We'll only use lines just to show you that. Okay. So this oxygen has 2. What does octet mean? 8. Okay, how do I do this? Well, I use lone pairs. So this is what I'm going to do. Here's 2, 4, 6, and then these 2, this oxygen now has 8. 2, 4, 6, 8, 2, 4, 6, and of course these 2, then you have 8. Okay, the key here is this word. You got to do the outer atoms first. And then ask yourself, do I have any leftover electrons? So let's pay attention to the total. The total was 24 valence. That was the inventory. So now I check if I have any leftover electrons. Let's see. I have 8 here, count them. Plus 8 is 16. Plus 8 is 24. So I have no leftover electrons. I used them all. You should ask yourself this question when you get to the third rule. Okay. Almost done, almost, but let's actually check. Well, if you look at carbon here, carbon does not have the octet. Only has 6. 2, 4, 6. So I'm going to copy it here again. Okay. And I'll put these. So carbon is not happy. So then people say, okay, well, let's check. Let's just add 2 more electrons on here. Okay. Maybe you shouldn't write this. Don't do this. And the reason why is you might erase, or you can erase it. But let's look at that. People usually say, okay, some people say, okay, let's just add 2 and give it happy. Well, okay. The problem is now you had 24. If you had 2 more, you had 26. That's more than what you started with. So this has 26. Where did the extra electrons come from? So you can't do that. Well, that's why rule 4 is here. Rule 4 is going to help you give carbon an octet by following a very simple rule. It says if there aren't enough electrons to give the central atom an octet, try multiple bonds. And in this case, it says use 1 or more of the unshared pairs of electrons on atoms bonded to central atom to form double or triple bonds. Very well. So if you look at this here, one of these oxygens, they're all happy. We have no leftover electrons. If we have no leftover electrons, then we need double bonds or triple bonds, whatever you need to give C an octet. If we had leftovers, then we would be done. But we don't have any leftovers, so that's why we need to do the following. So here's what you do. You just take any of these. It doesn't matter which one. We'll learn about this later. It's called resonance. We'll take any of these lone pairs on any of those atoms, whichever one you want. So in this case, I'm just going to look at this pair right here, and I'm going to make that a double bond. Okay. Of course, we have these here. Well, let's look. Is carbon happy now? Let's count. 2, 4, 6, 8. Yes, it is. Okay, did I take away from this oxygen? Remember, they double count. So nope, oxygen is still happy. So you have 2, 4, 6, 8. Once they all have 8, of course, with the exception of hydrogen, then you should be done. Since this was had a formula of CO3 minus 2, then anything with a charge, you should put the whole molecule or ion in brackets and put the charge on the outside. So this charge right here is that one right there. Otherwise, we wouldn't know what the charge is. So the take-home message here of this is, if you don't have any leftover electrons to give C an octet, or the central atom an octet, then you do double bonds. Now, are there times when you have leftovers, but still don't and you use them, but still you need double bonds? Absolutely. And you're going to see it with NO2 right here minus.